Hey guys, in this video I'm going to be showing you how to solve Leetcode problem 462. So the question that we're given is we have a non-empty integer array and we want to find the minimum moves needed to get all elements to equal each other. And one move is defined as incrementing or decrementing each element by 1. So with the example input here, we would want to set each element equal to 2. To do that, you just have to increment 1 by 1 and decrement 3 by 1. So that's 2 moves, and 2 would be our output. So there's really like 2 parts to this question. The first part and like the more challenging part is determining what number to set everything equal to. And then the second part is just counting the number of moves to actually do it. So for the first part, determining what number, it's going to turn out to be like about the median value. And I'll give a longer example here to show why that is. So say this is our integer array, and you don't know like what value you need. And we can't assume that it's going to be sorted either, but let's just say that it is. So if our array was just the values 1 and 10, like if that was our whole array we're looking through, it wouldn't actually matter. Like as long as you pick something between 1 and 10, it'll always be the same number of moves. So you could pick 1 or you could pick 10 or you could pick like 5 or something. So knowing that, like with our longer array, as long as we pick something in this range, 1 and 10 will be like their most efficient number of moves together. So we can just like not worry about those 2 outermost numbers and then do the same thing again. Get rid of the outer 2 until we're just left with 2. And then here again, like we can pick 5 or 7. Like the actual median would technically be 6, but we're just going to pick the 5 in this example because that'll be the easiest way to get the index from our array. Okay, so we're given an array that isn't necessarily sorted. So one approach to this, you could sort it right off the bat and then grab the middlemost value. But another way to do that is there's a function in C++ called nth element. And this function is going to take in like basically the array, and then you'll give it an index, and it'll give you, or it'll put the value at that index that it would be if that one spot was sorted. So we give it the start of the array, and then we give it where we want to be sorted, which is going to be the middle value, which we can get with size divided by 2. And then we're going to the end of the array. So again, this will just like essentially put at this spot whatever value would be there if the whole thing was sorted. So then to get that value, which I'm going to call median, and again it wouldn't technically be the actual median every time, but for our purposes it's good enough. Okay, so then we have the value we want to set everything equal to, so we can just define a move count variable and loop through our array to count the number of moves it takes to get there. Oops. So we're just going to increment that by the absolute value of the median variable minus whichever element we're on. And then we can just return the move count because we're just looking for that integer value. And that should be good. I'll run this to make sure it's working. Oops, didn't name that. Okay. Okay, and this actually ran slower. I don't know why, because I've run this exact same code before and it's been, like here it was 8 milliseconds, but this is going to be the fastest solution complexity-wise, because this function right here operates in O of n time or linear. So I'll just put that in there. And then obviously our for loop is also O of n. And the other approach I talked about where you sort the entire array, the sort function would just be in O of n log n time. So this is a little bit faster than that. Yeah. Thank you guys for watching.